My name is Nate Bach, and the following video will hopefully give you a preview of what to expect if you sign up for the Desmos class this summer through the district's Professional Development Week. You can email me any extra questions at nbach@pstschools.org. You can also reference plenty of my Desmos projects at tinyurl.com/bachdesmos. Before Desmos, everything was shown in pictures, it feels like, in math classes. They'd show you a picture of a wall, a ground, and the ladder leaning against the wall. And there's a lot of good math that can be shown through this, but it's not animated. It's very stagnant. There could be questions built upon the triangle that you see, the lengths of the wall, the ladder, and the ground based off Pythagorean theorem. In calculus, there's a lot of things on related rates. And related rates is about movement. So if a student could see the movement of a ladder falling down the wall, I feel they can get more out of the problem, understand more of the details and properties, so they can further understand and extend themselves through the math. A typical question might be just to verify. So if I have a wall and a ladder reaches up 8 feet up on the wall, and the ladder is specifically 10 feet in length, it should be stretching 6 feet away from the wall on the ground. And to verify that, you could do Pythagorean theorem. So you could do 6 squared plus 8 squared equals 10 squared. And you could show that 36 and 64 combined together should add up to 100, which it does. So not really solving anything here, verifying. The next style of problem could be finding one of those unknowns. So here you still have the ladder is 10 feet long. You know that the ladder is 6 feet away from the base of the wall. So you can maybe say L equals 6, but this time you're trying to solve for how high up does it reach. So you don't know the H. So here it's still Pythagorean theorem, but you're solving for the H in this story. And you would solve and get H is 8. But again, it's one picture for one problem, no movement. What Desmos can do is animate that movement. So at desmos.com, which we'll take a look at here, everything's free and you can really make a story dynamic. So you could keep that ladder 10. You could call that ground L. You can make the height up the wall H, but I want L and H to always be changing. I don't want L to always be 6 and H always to be 8. I want to watch it as the ladder slides down. And the key to this problem is Pythagorean theorem still holds, but this time I have two unknowns. The L squared and the H squared together combined to always make the 10 squared. Math before Desmos, you couldn't let L's and H's be part of the problem because it was always based off specific numbers, specific examples. With Desmos though, we can animate this story and I want to show you how. So on Desmos, if you go to desmos.com, let's look at the problem if I originally started with the specific numbers of 8 and 6. I can make a line, 8 over 6 x plus 8. Here's the issue with the line currently. It's too long. It does show the correct y-intercept of being 8 high. It shows the correct length on the ground being 6 over, but the ladder needs to be cut off there. It needs to only be in the first quadrant. What's nice about Desmos is you can immediately restrict based off this notation and say 0 less than or equal to x less than or equal to 6. Now I have the correct ladder being shown. Still, it's not animated. Still, it's a picture. There's no movement involved. But as you saw on the slide, I don't want to call them 6 and 8. I want to call them H and L. So I can do the exact same equation, but instead of using the 8, I'll be using the H. And we will rewrite it in a different form. Now the beauty of this is your domain is going to be changing based off how you slide the ladder, and you can equate with that using the L. So if you notice, there's 8s are H's, 6 are L's. That's what I want to have. I'm sorry about the parentheses. I need that to be squiggles. Now notice, it is saying I don't understand exactly what's going on with this problem because I expect numbers. We've always expected numbers. And that's why Desmos alerts you saying, wait a second, are you making me graph H and L as always changing numbers? That's what they mean by adding a slider. So you'll say yes to that. Now I can change the story so quickly by just changing H and changing L. Now I want to kind of put it in the correct region in that first quadrant. So I might make H from 0 to 10 with steps of 0.01. I'll do L the same, 0 to 10 with steps of 0.01. I'll make L start as 6 and H start as 8. It's the same story. Notice that my red story is the same as the black story. But now I can animate it. As I change H, the ladder's sliding down. As I change L, the ladder's pulling further away. Now hopefully you're starting to think, all right, I see it, but here's an issue. If H falls down, shouldn't the ladder be getting further away from the wall? Or likewise, if the ladder gets further away from the wall, shouldn't the height be falling? Right now, I've kind of ignored the restriction that the ladder needs to be a length of 10 at all times. I kind of have it where H can be whatever it wants and L be whatever it wants, but that's not true. They're both defined by that Pythagorean theorem. So what I might do is say, I'm going to control L. I'll let L be from 0 to 10. I am moving the ladder on the ground. That's where I am. But the H depends completely on the L and that forced length of the ladder being 10. So I'm going to put in the Pythagorean theorem using H equals. So I'm rewriting it and getting it as 10 squared minus L squared. Now, I don't get to control the L and the H. I'm only going to control the L, and the H is going to follow its pattern by sliding based off the ladder being a length of 10. So as my ladder gets further away from the wall, the height falls. And it should feel good to you that if I get all the way down to 10, the ladder's all the way on the ground. It is 10 feet in length all the way to the bottom. So now I can animate the story of the ladder falling from the wall or being pulled away from the wall and watching the ladder slide down. And that only took really 3 lines because you didn't need that first line up top. I'm animating. I'm showcasing a story instead of just giving you a specific picture of when L was 6 and H was 8. And there's so many extensions that you can do from this. I was thinking earlier today that what happens right when it gets to 10 if I want to keep pulling the ladder away from the wall. So instead of from 0 to 10, maybe I make it 0 to 15. And as I pull away, I want to see the ladder keep moving on the ground. But notice, as L gets bigger than 10, things aren't working. Because when you plug into the Pythagorean theorem, I got 10 squared minus L squared, and L is bigger than the hypotenuse. That's why it's saying the height is undefined because you've lost that triangle. But I can tell this story by adding in one more line. What I'm going to do is I'm going to say, hey, I want to showcase the ladder being on the ground. But that only happens fully on the ground when the length away from the wall is greater than the length of the ladder. So now, right now it's still falling down the wall, and it will fall down the wall until L becomes 10. Once L becomes 10, it's on the ground, and I'm activating the ladder being on the ground, sliding on the ground. But if you notice, the purple line is supposed to act like the ladder, and only the ladder, but it's highlighted the entire region of the ground. It's the entire y equals 0. So I want to add a new restriction to this. So I can have a couple restrictions placed together on this ground ladder. And what I'm going to do next is I'm going to say, this is only true when I do L minus 10 less than or equal to X less than or equal to L. Now what hopefully works is the red tells the story of the ladder falling down the wall all the way to 10. Then from 10 to 15, it's going to show a purple ladder, kind of changing the color of the story, as it slides the ladder on the ground from 10 to 15. Now the students can see a whole story of the ladder being red falling down the wall, and when it hits 10, it's on the ground sliding away. All of that from 4 or 5 lines on Desmos. That animates the story, animates the learning, so the kids can truly see the dynamics of the properties of L and H as the ladder changes, as the ladder falls down the wall. And the beauty of this is, I had the ladder be 10 at all times. You could quickly change the length of the ladder. Maybe you want the ladder to be a dynamic ladder, and you say, I need the ladder to be anywhere between 0 and 20 in length. And with a quick deviation of that, I'm going to now change the story, but instead of it being 10, 10 becomes D. Oops, capital D. And this changes. Basically, anywhere where you see a 10, you're changing it to the length of the ladder. And now you can tell the story. And as it slides, this is a 14 length ladder. As it slides down the wall, it's going to be sliding down the wall all the way to 14. But from 14 to 15 now is a little piece where the ladder is fully on the ground. So I've now not only made the L and the H dynamic, I've also made the length of the ladder, and I called it D, dynamic. Everything's dynamic, so your story can change based off the length of the ladder that you want. That's the idea of Desmos. The idea of Desmos is to animate our stories. I don't want to take a picture anymore. I want to take a video. But what's so cool is it's not a video from a camera. It's a mathematical video where you are showcasing your math properties via the animation, all in Desmos. That's how I'm going to introduce you to it. And our end goal will be something more visual, like this scissor lift. So the scissor lift here has similar properties to the ladder falling. I'm going to make it a little bit bigger. Those orange line segments, think of those as multiple ladders. So it's kind of like you have 6 ladders falling off of walls. And as this scissor lift gets higher and higher and higher, the ladders get taller and taller and taller. And the base plates, which are blue, the top and bottom, are always a specific length long. And you animate the scissor lift all the way to the top. So I produce that here. I have my scissor lift. The orange lines, think of those as kind of like ladders, and there's 6 of them. And as I, whoa, music in the background. As I change the slope of a ladder or a slope of a leg of the scissor lift, it gets taller and it can get all the way down to the ground. And what the C equals 9 part is it controls how long each leg is. So maybe I want my legs to be 12 long, and I can still showcase my scissor lift as it goes from the ground all the way to the top. Those animations are a little bit more advanced, but that's why it's a whole day event on this professional development to help us transform basic problems like a ladder next to a wall and animating that to ones like the scissor lift. And by the time we hit the afternoon, my goal is to then have us be able to create our own projects. And it doesn't matter if it's in elementary school or middle school or high school. If you're focused on geometry, focused on algebra, or all the way up to calculus, there are many problems that we have been trained to teach that are a specific picture, a story problem that is always defined in one picture. I call those stagnant. And our goal is to change that into a dynamic story, a story that is changing at all times, making a math movie. But that math movie is not from a camcorder, it's from Desmos. So hopefully this helps showcase what you can be learning through the Desmos Professional Development class later this summer with me. Thanks again. Bye.